Hello everyone. Now we are going to discuss the group project of Mechanism Sessional ME29002. And myself Pendem Ganesh and my roll number is 20ME10061 and my name is Sumithraj Pilagunla and his roll number is 20ME10062. And we have selected to discuss the question on synthesis and make a simulator for the parallel jaw pilot as shown in tutorial sheet 1 question D. Identifying the Chebyshev 4-bar mechanism in the chain for straight line generation of 1 point to the lower jaw and then synthesis. Add any new idea you might have. And now over to Sumithraj.
We in this video will describing how to synthesize and make a simulator for parallel jaw player. Hence, fourth, identifying the Chebyshev 4-bar mechanism in the chain which is used for straight line generation of 1 point of the latch. Now the question arises what the Chebyshev 4-bar mechanism is. We say Chebyshev 4-bar mechanism is a 4-bar double rocker mechanism. It converts mechanical linkage to rotational motion to a symmetric line. It was named after its inventor Pafnati Chebyshev. The straight line linkage conforms a point P, the midpoint of link R3, and a straight line at two extremes at the center of the traveler. The point P slightly deviates from a straight line. The proportion between the links should be L1 is to L2 is to L3, which is equal to 4 is to 5 is to 2. L4 can mathematically be derived from the equation L4 equals to L3 plus root of L2 square minus L1 square. So from the above equation, we can also come to the conclusion that the lengths of L2 and L4 are bound to be equal. Parallel jaw players are prime examples which use Chebyshev 4-bar mechanism in it. Parallel jaw player is kind of players which excel at crimping and grasping near the tips. Since they apply uniform pressure across the whole face as the jaw faces stay parallel. These players may be used in a pinch to hold or turn small fastener without deforming its face. These are two backtings which slide in the slots. Conditions to get parallel crimping surfaces of the jaws are. The first condition is for each jaw the distances to clumping surfaces from center line of slot and from the center of the hole should be equal, and the second condition is center distances of the holes from the handle are also equal. Now we will see different parts of the parallel jaw player and visualize how a parallel jaw player works using the SolidWorks software. As the name suggests, the jaws of parallel players remain as such along their entire length. So you do not worry about the positioning metal within them. As a result are uniform throughout. These players are ideal for threading and flattening out kinks in wire, jump rings, hair rings, fittings and much more besides, but they are also useful for creating nice, clean, blunt hands to the uniform shape and sharp right hands. The screw in the lower jaw of the player helps in the adjusting the change of maximum jaw opening of players. It is a great use when the tool used for substances having different diameters. Now we will be seeing screw alerts the jaw opening range. When we tighten the screw, it reduces the maximum jaw opening. Once we loosen them, the joint changes and attaining its maximum load. And let us see how it works. To understand the functioning of the parallel jaw players, we must look into the limiting cases of the Chebyshev 4-bar mechanism. Here are the two limiting cases of the Chebyshev 4-bar linkage, which gives an estimation of theta minimum and theta maximum from cosine laws. We get L3 minus L2 whole square equals to L0 square plus L1 square minus 2 L0 L1 cos theta minimum. It implies that theta minimum is equals to cos inverse of L0 square plus L1 square minus L3 minus L2 whole square by 2 L0 L1. In the similar way, L3 plus L2 whole square equals to L0 square plus L1 square minus 2 L0 L1 cos theta max, which implies theta max equals to cos inverse of L0 square plus L1 square minus L3 plus L2 whole square by 2 L0 L1. But as we know, the ratios of L1 and L2 and L3, so by approximation we can get theta minimum equals to 36.8 degrees and theta max equals to 101.54 degrees. Now we'll see the MATLAB simulation parallel job layer. From the MATLAB simulation, the parallel job layer, which we can observe that the middle point of the orange link moves parallel to the base link, which describes the purpose of Chebyshev 4-bar mechanism. With this, we complete the project we were assigned to do. Thank you so much, sir.